Okay, today we're going to finish off the rest of section 3.4 with two proofs. It shouldn't take too long to work through the two proofs. The remainder of the day then you'll have to finish the assignment for section 3.4, which will be due tomorrow. Okay? Alrighty, so let's finish off section 3.4. The first proof is called the linear pair perpendicular theorem. And it goes like this. If two lines intersect to form a linear pair of equal angles, then the lines are perpendicular. Okay? If two lines intersect to form a pair of to form a linear pair of equal angles, there it is, then the lines are perpendicular to each other. So as you're jotting that down, I'm going to sketch out a picture. Excuse me. Right, in my picture, I'm going to give you that we have a linear pair. I'm going to call them angles 1 and 2. And those two angles are equal to each other. Angle 1 and angle 2 are equal. Please notice if I choose my highlighter tool here, we have a linear pair of equal angles. That's the hypothesis. That's what's given to us. Okay? Now what we're trying to prove then is that the lines are perpendicular to each other. So line 1 and line 2 are perpendicular. Okay? Now, like always, if you need a little bit more time, just pause the video so that you can get anything you want to into your notebook. But I'm just going to keep on going, knowing you can pause at any time. Okay? So I'm going to start with the given information. So I'm going to start with angle 1 equals angle 2. Given. And then next, we remember that since angle 1 and angle 2 are a linear pair means two angles that are supplementary. So two angles that add up to 180 degrees. So using the definition of a linear pair. Okay? Now, since angle 1 and angle 2 are equal, anywhere I see one of them, I can replace it with the other. So what I'm going to choose to do is take the second statement, angle 1 plus angle 2 equals 180 degrees, and I'm going to replace one of the angles with what it's equal to. So as an example, I'll leave the angle 1 where it's at. I'll leave the 180 degrees where it's at, but I'm going to replace angle 2 with what it's equal to. And back up in our first statement, you see angle 2 is equal to angle 1. And whenever we replace something with what it's equal to, that's called a substitution. Okay? And then how do we add two of the same thing together? Back in algebra days, what was 1a plus 1a? 2a. What was 1q plus 1q? 2q. So what's one angle 1 plus another angle 1? It's going to be two angle 1s. So we can simplify the addition on the left-hand side by combining angle 1 plus angle 1 to get two of the angle 1s. Right? And by doing that, we create multiplication. So to get rid of multiplication, we divide. So we'll divide both sides by 2. On the left-hand side, the 2's cancel, leaving me with angle 1. On the right-hand side, 180 divided by 2 is 90. And since we divided both sides by the same thing, we were obviously using the division property. And now since we found that one of the angles is 90 degrees, of course, since angle 1 and angle 2 are equal, that also means angle 2 is equal to 90 degrees. But when the angles formed by two intersecting lines is 90 degrees, that means that the two lines then are perpendicular using the definition of perpendicular. Okay, and we have our proof that line number 1 is perpendicular to line number 2. All right, like I mentioned before, feel free to pause the video if you need to get the last few steps down into your notebook. Otherwise, though, I'm just going to move on to the second proof for today, which is called the perpendicular transversal theorem. Okay, and this is the second proof we're going to work through today that'll finish up section 4. So here we go. If a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the second line. If a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the second line as well. Okay, so as you guys are jotting that down, I'm going to start drawing a picture so we have something to work with. Okay, and the given information here would be that line 1 and line 2 are parallel to each other. Line 1 is perpendicular to line 3. So the given information, let me use my highlighter tool here. The given information is we have two parallel lines. So that would be line 1 parallel to line 2. And the second part is we have a transversal that's perpendicular to one of the lines. So that would be the second part of the given. Okay? And what we're trying to prove then is that the transversal is perpendicular to the second line. So we're trying to prove that line 2 and line 3 are perpendicular to each other. Okay, so like I've mentioned a couple times, feel free to pause the video if you need to get some of that down. But otherwise, we're just going to move ahead with the proof. So the given information again, line 1 parallel to line 2, given. I'll put a couple arrows on the lines to remind you that those are perpendicular to each other, or sorry, parallel to each other. And remember, because they're parallel, we know all kinds of things about angles, corresponding angles, alternate interior angles, alternate exterior angles, consecutive interior angles. You got to kind of keep those in mind. Also, given was that line 1 was perpendicular to line 3. And to indicate perpendicular, I'm going to put a box kind of anywhere where those two lines 1 and 3 intersect. Okay, so how can we get to the point then where we can say line 2 and line 3 are perpendicular? Well, what we're going to need to show that line 2 and line 3 are perpendicular to each other is we need to show that one of these angles where line 2 and line 3 intersect would be 90 degrees. So we need this angle to be 90 degrees, or this one, or this one, or this one. We need one of these four angles to be 90 degrees. we don't need to do all four, but just at least one of the four have to be 90 degrees. Okay, so to help out, I'm just going to put a couple of numbers in. As an example, I could use, oops, sorry, this is jumping around on me. I could use that angle right there and this angle right there, just as an example. There's lots of options, but this is just one way to go. Okay, so what I can start with is, I can say that angle 1 is equal to 90 degrees. Okay, how do I know it's 90? Because we were given that line 1 and line 3 are perpendicular, so we're using the definition of perpendicular. Then I can say that angle 1 is equal to angle 2, right? How do I know angle 1 and angle 2 are equal? Remember, line 1 and line 2 are parallel to each other. Let me choose my pointing tool. Remember the arrows? Okay, line 1 and line 2 are parallel to each other. So therefore, angle 1 and angle 2 are going to be corresponding. Corresponding, again, angles in the same relative position. So angle 1 is in the upper right-hand position, angle 2 is in the upper right-hand position. So those are called corresponding angles. So angle 1 is equal to angle 2 because they are corresponding angles. Right? And since angle 1 is equal to 90 degrees and angle 1 is equal to angle 2, we have two things that are each equal to the same thing. We have two things that are each equal to angle 1. Therefore, we can say that angle 2 is equal to 90 degrees. And that's called the transitive property. When two things are each equal to the same thing, they have to be equal to each other. That's the transitive property. And since angle 2 has to be 90 degrees, I could then insert a box into that corner just to give you a visual. And then that tells you, because that one's 90 degrees, that means that the two lines, number 2 and number 3, are perpendicular to each other using the definition of perpendicular. And we have our second proof. Okay, so that's it. That's all that we have. That finishes off section 4. So please use the rest of the hour to work on that assignment. We'll go over questions on that one tomorrow right away, turn it in, and then go ahead and get ourselves started on section 5. Hope you're having a good day. Make sure you don't have a hat on, and we'll talk to you tomorrow.